right. So if you line up where your domain should be, then this really shouldn't be a problem. Your domain and your range. What is your range on your tangent curve? All real numbers. So if we change your amplitude, there really is no amplitude on a tangent curve. You start with your regular domain, right where your exception is. Then you take this and you substitute it in for the x. And you solve for x. And so here is your domain. You have to bring down your qualifier there. And your range, of course, was all real numbers. Okay? But if you don't know those original domains, you're going to be stuck. You're going to really be stuck. Again, this says n is any odd integer. So if you set up your chart at 1, 2, 3, 4, 5, went by numbers and did it at 1, 3, 5, 7, you could do your x-axis that way and put it at the odd integers. Make your asymptotes. Your tangent still goes like that, so you would be fine doing that. You didn't have to graph them. If you did, that was great. Questions? Yes. There's not. This is our original domain for a tangent curve. After we transform it to this, we have a new domain for your transformation. Your original tangent starts with the odd 90s, where there's your n pi over 2, where n is odd integer. We have to keep that part, set it equal to that now, and solve for your x. So we always start with your original, and then we put the transformation in there. A cosecant and a cotangent have the same. This is your n pi, where n is any integer. You start with your basic. Whoa. Someone's mad. You start with your basic domain. Now, just take this and substitute it in for the x, right here. Solve, cross multiply, and solve. Remember when I was trying to get you yesterday to think these things out logically? If you take half of your curve, are you shrinking it or stretching it? Stretching it. You're stretching it out to half of your curve in your normal time, right? So what are you going to do to your asymptote? You're going to stretch that out too, right? If you're shrinking by a factor of 1/2, you put 1/2 of your curve there, you have to multiply by a factor of 2. So if you just took this guy right here and multiply that by a factor of 2, you come up with your answer. Or just use your formula and find it that way. Think of these logically. They really make sense if you think of them logically. You got to think in terms of a stretch and a shrink though. Okay, and again, we did not change your domain. What did this negative out here do? Reflect it over the x-axis, right? Okay. Yes?
How come for this question you wrote where n is any integer?
Yes.
You wrote any odd integer.
Because the n pi over 2 is any odd. The n pi is any integer. This comes off your basic sine curve. And if we move this and just did sine 1/2 x, my sine curve is going to look like this. Okay, so now look where my asymptotes go. Here and here. So at 0 pi, at 2 pi. That's what's giving me this guy right here. My normal sine curve goes like this. So my zeros are here. At the 0, at the 1 pi, at the 2 pi. See it? That would be my n. That would be because it works off of your reciprocal function where your zeros are. The only two that you have to memorize, and remember the c's are the same. Here's a secant. Secant is like tangent. So start with your basic secant domain and modify this. Put this in place of x. So solve this for x. Yeah, it's 3/2 of any number when n is an odd integer. So if you wanted to graph this, you could easily set it up and put n as an odd integer, 1, 3, 5, and just keep multiplying them. Now, your domain changed and your range changed because of this. Your amplitude is not negative 2. Remember, your amplitude is always positive. The negative is a reflection. But your amplitude is now going, your cosine's going from 2 to negative 2. Therefore, your secant goes from negative infinity to negative 2 and from 2 to infinity. Yeah? Okay? Is this making sense? Okay? I don't care how bad the n comes out, it still works all the same way.
Is that supposed to say Annie or Ann?
N is an odd integer.
Oh, so
It could say any odd integer or any integer, any odd integer or an odd integer, as long as it's an odd integer. And the last one you had here was a cosecant, which works like your cotangent. Okay, again, set this piece right in here where your x used to be. Set that equal to x and put it in here. And pi, solve it. Keep this qualifier. You changed your amplitude to 1/2. So now your sine curve is going from negative 1/2 to positive 1/2. So your cosecant curve will go from negative infinity to negative 1/2 and from 1/2 to infinity. Does that part make sense when we change the amplitudes? The only one that's not affected is your tangent or your cotangent. Because they're all real numbers anyway, so they're not affected. If you didn't know those domains, this is difficult. This is very difficult. When I purposely did these guys that had the pi's in there and the n's over 2's, because they're a little bit tougher to graph with these in there because you're using radians, but I wanted you to use your domains in here. That's why I didn't say sketch. The sketching, like Alex said, is a lot harder. Questions on any of these?
I thought mine were all wrong because I thought the graphs were wrong. They were actually all right. The graphs just didn't make sense.
The graphs are a little off because what you have to do is relate your pieces in here to numbers. If this is your pi over 2, your pi, your 3 pi over 2, your 2 pi, just multiply it by 3.14. This is like 6.2. This is like 4.7. This is 3.14. This is 1.5 something. So just relate it to numbers. Use pi as 3.14. Or you can just, if I'm looking for any integer, I could set this up like this. 1, 2, 3, 4. I could use those and put them in there. Okay. All right, your next one. You had one more, transformations. Okay, now I want the transformations listed on this. If you can graph it, all the better, but I want the transformations listed. And remember, when I ask you for them in order, go for where your x is. So my first thing I'm going to worry about is this in here. This changes my frequency. I need to fit 2 in here. So I shrunk it in, didn't I? Didn't I change the period here by putting this 2? This 2 gives me a horizontal shrink by a factor of 1/2. It's the opposite factor. I took my period and I cut it in half. Instead of being 2 pi, it's now pi. Makes sense, right? Okay, I come out here, I see the 5. The 5 is my amplitude. What did that cause it to do? This, stretch vertically. What did the negative cause it to do? Reflect over the x-axis. And then this guy, a vertical shift up 3 units. So you can give me the transformations. The easiest way to figure out where to make your points is to start with your sine curve. Your sine goes 0, 1, 0, -1, 0. Is everybody getting used to this? Far easier than picking up your calculator. Now, I'm still okay by my horizontal change. Right here, I could multiply everything by -5. So I will get 0, -5, 0, 5, 0. And then another one that's going to change my vertical, my range, is this +3. I'm going to add 3 to everybody. This is the easiest. I do this, guys. I cannot keep track unless I do this. I have no spatial quality in me at all. So if I don't do this, I can't figure out where my graph is. So once you have this, this is how you follow this. Instead of starting at the 0, you're at the 3. Then you're at the -2. Then you're at the 3. Then you're at the 8. Then you're at the 3. There's one cycle right there. See it? One cycle. No, Dan? You don't see it? Did you see what I did with the 0 and the 1s? Then we changed it?
So you did it there?
Yep. We started with this. This is going to change my range, multiplying it by 5, right? Isn't that going to make it go to 5 to -5? So we did that. I put the negative in there at the same time because that will show the reflection. And then we also had to pick this whole thing up and walk it up 3 units. So I added 3 to everybody. And this is where my sine curve goes. Easiest way to graph this. Yes.
Information. Is it horizontal shrink by a half?
Yes, because what happens is this. You have to fit 2 of them in here now. So your period was cut in half. It works the opposite way. If we use a half, it's a stretch by a factor of 2.
I'll just put the number, make it into like a
I would like, it's always the reciprocal, because that's why I said the sines and the cosines work a little differently than your normal ones do. Because if you're actually messing with the period of it. If you just write to me horizontal shrink, I'm okay with that. Once you look at the period to graph it, you'll see the difference. Okay, this was interesting. 1/3 of your cosine curve fits in 2 pi. I need to make a full one. So think about this logically. If 1/3 fits in 2 pi, if I double that 4 pi, how much of my curve do I have now? 2/3, right? If I go another 2 pi at 6 pi, don't I have the whole thing, 3/3? Because your period is 2 pi over b. 2 pi over 1/3. This says flip this fraction. 2 pi times 3 over 1. There is my period, 6 pi. Out of 6 pi, you need to go through 4 quadrants. So 6 pi over 4. Every 3 pi over 2, I hit a quadrant. Every 3 pi over 2, I hit a quadrant. Now, if you just gave me a sketch from here to here, from 0 to 6 pi, and you made it go like this is going to work too. You got your sketch there. Cut it in half. There's your 3 pi at the halfway. If you just kind of show me a little bit of it, at least I know what you're doing. Right? And again, this is going to change my amplitude. Here's my cosine curve. I'm going to multiply it by a factor of 6, and then I'm going to drop it 2 units. I'm going to subtract 2 off of everybody. This is what I graph right here. So when I find this, I'm 4. Then my next tick mark, I drop to -2. My next tick mark, -8. My next one, -2, back up to the 4. Good? Okay. These guys were just kind of, you had to kind of fill it in. You were stretching vertically by a factor of 4. A stretch means you're changing your amplitude. Here's your amplitude change right here. And that, oh, this one also had an amplitude change of 4. Okay? Then you shifted to the left. Remember, inside the parentheses, it goes the opposite way. So that's giving it to the opposite way. Good? All right? Tell me if you have any questions. I'll just go through these guys. Again, down 5 units. If that hits your eye, get rid of the ones that's plus. you're shifting vertically by a factor of 1/2, it's going to be this one or this one. And since you went down 5 units, it can't be A, so it's B. Here's another one with a period. You had to find your frequency off of this. Were you guys okay with this one?
I didn't get the 14th one.
Because what happens is you're working it backwards. Your period says 2 pi over B. So now if I give you your period, you have to set this equal to pi over 7. Okay, and now you're going to solve for B. So that's what we're looking for. So you're going to cross multiply. 14 pi equals pi B, and you're going to divide by pi. So B is equal to 14. That's where your 14 came from. And you had to work it a little bit differently. And an amplitude of 4, it was either going to be this guy or this one. And your 14 had to fit right in here, where your frequency goes. You had a little bit of a backwards thinking. And this one too, you had to work with your period. You had to get back to the B. You know, if you can always do it reverse. An amplitude of 2, I'm obviously either this one or this one. So if my period is this, take this and do 2 pi over B. Isn't that my period? It's a multiple choice. So just work from the ones that you narrow it down to. Okay. All right. That one's probably similar. I want to get to the graph. Did you guys get the graph? Okay. Look what this is. This is pi. Oops. This is pi right here. So how many cycles were in pi? How many cycles are in pi? 1. So how many cycles would be in 2 pi? 2. That's where that 2 came from. So be careful. They always love to do that. They always love to change the scale so that it doesn't catch your eye. It looks like it's in 2 pi. The amplitude is 3. Everything else was nice on that one. And this last guy, you had an amplitude of 2. There's no shift in this. Here's pi. So in pi alone, you've got 1, 2 in pi. How many are you going to have in 2 pi? 4. There's your 4. Okay? 2 in pi alone. So you got 4 in 2 pi. Okay. Any questions?